Earlier this year, the Minor Planet Center at Harvard announced the discovery of an unusual asteroid, designation 2018 CN41. A citizen scientist spotted it first, and here's what made it notable. It came within 150,000 miles of Earth, making it a near-Earth object, the kind astronomers monitor closely in case it's on a collision course with our planet. 17 hours later, the Minor Planet Center deleted it from their records because it wasn't an asteroid at all. It was a Tesla. Elon Musk had strapped a car to the front of a rocket and shot it into space, and now it's just out there, drifting. One more object in an increasingly crowded void.
A decade ago, right, there were about 1,000 working satellites. There's now 12,000 working satellites. And in the next decade, we anticipate we may break the 100,000 mark.
This week, I'm going off the radar with Dr. Jonathan McDowell, an astrophysicist who's been tracking every rocket and satellite launched into space since the 1940s. He's watching what happens when all of this stuff reaches the end of its life, and he's concerned.
So now we're seeing several satellites a day being disposed of using the upper atmosphere as an incinerator.
Some burn up, some crash into the ocean, some get shot even farther out into what's called a graveyard orbit, or beyond that to orbit the sun itself, but none of it just disappears. Today we'll learn why space technology is critical and what the environmental cost could be if we don't start managing it responsibly. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. You may have heard the term space junk, the catch-all term we use to describe the human-made debris orbiting our planet. The first rocket was blasted into space in 1944. Since the start of the space age in 1957, about 7,000 rockets and almost 24,000 satellites have been launched. More than 15,000 tons of material are trapped in Earth's orbit. Some are the size of a school bus. And as these objects hurtle through space at over 17,000 miles per hour, they frequently crash into each other, breaking up into more, smaller pieces. Astronomers estimate that there are over 140 million pieces of space junk between 1 millimeter and 1 centimeter in size. If you're thinking that's a lot of debris, you're right, and it's causing some problems. Entire orbits around the Earth could become unusable for the foreseeable future because of how much space junk is in that path. And active satellites, including the International Space Station, which houses astronauts from around the world, are particularly at risk. A piece of debris hitting a GPS satellite could interrupt global navigation capabilities here on Earth, and the space station getting smacked with debris could injure or kill its occupants. In October, a piece of burning space debris came crashing back down to Earth in Western Australia, raising concerns about the risks of impact here on Earth's surface. So what does the future hold for our graveyard of rockets and satellites in space? And what can be done to keep everyone safe? My guest today, Dr. Jonathan McDowell, is here to fill us in. He's an astronomer and an astrophysicist working at the Harvard-Smithsonian Center for Astrophysics. And today, he's going to help us navigate this orbital minefield. Dr. Jonathan McDowell, thank you so much for talking to me today. There's a lot of buzz going on right now about what's floating around up there and possibly hitting planes. So we need to get the record straight, which I know the story's still kind of unfolding. But I'm really fascinated by your history here because you have been keeping track of this stuff for a very long time. Can you give me a little brief history on not only your education, but kind of your personal mission here?
Right. I mean, I got absorbed by outer space as a child. Started watching Doctor Who when it began. My babysitters were physics graduate students. And so, and when I was 7, my dad did a sabbatical at NASA Goddard. So ever since then, I've had the space bug. And I got frustrated by how how hard it was to get the information. I see, our move into space as this incredibly historic period, that if there's a future 1,000 years from now where most people don't live on Earth, they're going to want to look back to and know all the details of how we did these early steps. And so my mission is to preserve that information, the technical information that I felt was getting lost. And so I've been collecting that information and trying to distill it and put it on my website and organize it. Partly, it's been great that people now have been interested in that and subscribed to my newsletter and so on. But in my mind, my real audience is like many years from now. So that's really the mission.
What kind of data are you putting out there? What are you keeping track of?
Well, I have the list of all the rocket launches into space since the 1940s, all the ones that I've been able to find, all the satellites that have gone up, what they did, who owns them, how they're moving. And so, that originally started as just trying to record what humanity was doing. And doing that, it became impossible to ignore the environmental impact that we're having. And so I've sort of moved into more and more the issues of space sustainability and how we're affecting the environment, what the risks are of space debris, of anti-satellite weapons, of all these other possible applications, as well as a particular hobby horse of mine is documenting what we're doing in deep space beyond Earth orbit as we go to the moon and the planets, because that is hugely underdocumented right now. There is very little regulation. That used to be not such a problem because there were only basically two entities doing deep space. There was, the Jet Propulsion Lab with NASA and the Institute Kosmiczewski Slavovania in Moscow, right? And now you've got, developing countries and commercial companies and so on with moon probes and Mars probes and stuff. And so that's becoming an issue. So that's one of my little rants that I do. So basically get the data, make it open, share it with everybody so that it's preserved and available.
I guess I'm surprised that this doesn't already exist somewhere else, that you are doing this and that one of these other groups is not. So how are you getting this information, especially given the fact that a lot of these are, not public sector, they're private companies?
Exactly. Yeah. Well, so there's a number of sources. I mean, for the Earth orbit stuff, the Space Force tracks most of it. And amateur astronomers and asteroid astronomers pick up a lot of the rest. Again, for the deep space stuff, the asteroid astronomers sort of pick up these deep space objects and go, well, that's not that's not one of ours. Throw it away. And I'm like, hey, throw it this way. So I sort of collect the things that other people aren't interested in. I'm not above harassing phone calls to engineers in various space companies going, can you really share this data? It would really help us. So I use all the methods at my disposal to try and fill in this enormous crossword puzzle of what's going on up there.
Do you sleep? It seems like a 24-hour-a-day job.
Occasionally, but yeah, having a life would have been nice, but never mind.
Okay, so how often is something being launched into space, like worldwide?
Right. For orbital launches going into orbit around the Earth, we're now running at like several a week, about 250 a year. Of launches, and many of those launches carry many satellites. And so right now, it's about an average of about 4 new satellites a day go up.
Wow.
And which is just enormous. And so, yeah, it's quite a challenge keeping track of it all. And we're starting to see now that sharp rise, there's been, A decade ago, right, there were about 1,000 working satellites, which was already a lot compared to what we had in what many people think of as the highlight of the space age with Apollo and so on, where there are only a few hundred satellites. There are many more satellites. They last much longer. In the past decade, that number has increased by over a factor of 10. There's now 12,000 working satellites. And in the next decade, we anticipate it may go up by another factor of 10. We may break the 100,000 mark if all of the companies that want to launch these internet constellations go ahead with their plans. And so we're at a time of vast increase in the launch rate. And a lot of these satellites, in contrast to 20 years ago when the high geostationary orbit was the popular place to go, a lot of these satellites are going to quite low orbits around the Earth. And they have relatively modest lifetimes. They retire them after about 5 years and, replace them with upgraded versions. And so that means about 5 years behind this steep curve in launches, there's starting to be a steep curve in reentries. And so now we're seeing several satellites a day being disposed of using the upper atmosphere as an incinerator. And that in the next 10 years is likely to go up to perhaps 15 or 20 satellites a day. And so that's another concern for the environment. We don't really know yet what the environmental impact of that will be. It may be small, but it may not be.
Who's the governing force here? Who gets to control all of this stuff? And are there any rules?
Yeah, the governing law is the 1967 Outer Space Treaty, which is administered by the Committee on the Peaceful Uses of Outer Space at the United Nations. And that has some general principles. And one of the principles is everything that happens in space should be under the sponsorship of a nation state. And so if you are a private company wanting to launch a satellite, you need to be licensed by some government, which government then takes on the responsibility of what's called supervision and control. So that if my satellite, say, crashes into Australia, like one did the other day, right, onto some Australian farmer's land, the farmer doesn't get to sue my company. The farmer gets to complain to the Australian government, who then complains to my government, and they deal with it. And then it's up to my government to decide if they want to take any action against me. And so everything has to go through the nation state level, which is not very flexible, but that's where we are. And, because in the 60s when these treaties were negotiated, right, the only people launching stuff basically were the US government and the Soviet government. And so people weren't thinking in terms of, even though the very first commercial satellite was launched by AT&T back in 1962, but that was pretty unusual back then. And so people weren't really thinking in these terms. And so we have this Cold War legal infrastructure left over that is, we're trying to kind of squeeze the modern day commercial dominated new space into that jacket, and it ain't fitting very well. And so in the United States, if you want to launch a rocket, you have to get the permission of the Federal Aviation Administration. If you want to put a satellite on that rocket and use it in orbit, you have to get permission from the Federal Communications Commission, which is a bit odd, but it's because if you want to get anything useful, you have to transmit using radio waves, and there was an existing, control over the radio waves, and that role for the FCC has grown to include, you got to prove to the FCC you're not going to make a lot of space debris and stuff like that. And so there is, in principle, a regulatory process to control what's happening up there. It's not as rigorous as it might be.
Okay, I was going to say, if it was written in the 60s, I'm guessing there's no incentive to design anything with low environmental impact or end-of-life satellite plans. Like, where is there incentive on how the end of their lifeline?
There is something in the Outer Space Treaty, right, that and related treaties. There's a treaty on there's a thing called the Liability Convention. There's a thing called the Registration Convention. So you have to, if you launch a satellite, you have to register it with the United Nations. And if it falls on my head, your country is liable to my country. And so there is some, therefore, incentive to make sure that you don't cause damage due to a reentry or something like that, or damage to other people's satellites. There's clauses in the Outer Space Treaty about not interfering with other people's space activities. But there's nothing, if you take the risk and go, well, this satellite's going to fall out of the sky, but it probably won't hit anybody, and you get away with it, there's nothing against that. There's no rule that says you're not allowed to take that risk. You're going to get, potentially punished if the risk doesn't pan out. That's all. And that's not really adequate. The other thing that's happening, right, is that there are international norms evolving in the absence of more recent treaties. And so there's an organization called the Interagency Debris Committee that issues recommendations. Basically, technical experts from different space agencies get together and say, what the rule really should be is this. And then other countries go, well, no one's going to tell us what to do, but we need to make our own rule. And since you already got one here, we'll copy that one. And so that over a period of time, and not all at the same time, different countries start adopting these norms, and they become essentially required. And so one of the norms is this very precious orbit called the geostationary orbit. That's 23,000 miles up. That's where all the big television satellites are. And at the end of your satellite's life, you're meant to use the last few gallons of fuel to boost it up to what's called the graveyard, which is a bit of orbit that isn't so useful, and you can just leave stuff floating there for the next million years and no one will care. And so for a couple years ago, a commercial satellite failed to save enough fuel to get all the way up to the graveyard and got stuck still in the valuable bit. And they actually got fined by the Federal Communications Commission for not doing the right thing. And that was the first time someone actually got fined for behaving badly. So we are starting to see the glimmerings of some of the space police.
Okay.
Right? Pull over, you're going over the 17,000 mile an hour speed limit. And so I think that's, that kind of thing is going to come. We're still arguing about what the rules should be. Things are getting really crowded. And the problem is in low Earth orbit, there aren't the same sort of agreed norms perhaps as there are in the higher orbits. Those are the ones the low orbits are getting really crowded now. And a huge development that's happened in the past 10 years is that China has deregulated this industry. So there are a lot of Chinese commercial startups now, as well as Western commercial startups. And so you have all these Chinese companies and all these Western startup companies with stuff in orbit. They're all using the same orbits and going close to each other, and they're not talking to each other. And so it's a bit of a mess.
Okay, lower orbit. What's hanging out there, and is that the same level as the International Space Station?
Yeah, and so we talk about it's unfortunate we talk about LEO, low Earth orbit, and the official definition of LEO is between 200 and 2,000 kilometers above the Earth, like 1,200 miles above the surface of the Earth. But that kind of glosses over a really big distinction, which is that the lower half of that orbit is very different from the upper half. In the lower half, there's still just enough outer Earth atmosphere that when you're whizzing through it at 17,000 miles an hour, it's enough of a headwind to make your orbit slowly shrink and eventually you re-enter. And so if you don't keep reboosting your orbit with rocket fuel, you will come back down and burn up in the atmosphere within about 20 years, maybe less. Whereas above about 400, 500 miles, the atmosphere has gotten so thin that you're going to stay up there for centuries. And so the populations are very different in those areas. The upper area is mostly full of dead satellites and rocket stages left over from the Cold War. Whereas in the lower region, those get cleaned out by the reentries, and it's dominated by new active satellites. And so the upper part of that lower thing, so about 400 miles, 500 kilometers, something like that, is the densest area. It's like as high as you can get, and still you deliberately launched to the point where if the satellite fails, it still will come down in about 20 years. So you won't leave it there as junk. But it won't come down much sooner than that because you want to use it. You don't want to keep boosting it with rocket fuel. And so there's this relatively narrow band around the Earth that's like the sweet spot for these satellites. And everyone is going there, and it's super crowded right now.
Do they ever crash into each other?
Well, we had one bad day in 2009 where two large satellites smashed into one another at 26,000 miles an hour and reduced each other to smithereens. And about 1,000 of those debris pieces are still orbiting the Earth today.
Oh.
And causing a risk to other traffic. And since then, people have been a lot more careful about dodging. And the problem is that, so you go, okay, where's my satellite going to be tomorrow afternoon? And what other satellites might come close to it? Well, fine, but especially in these lower orbits where there is a little bit of air, where space weather can affect the density of that, that's going to add some uncertainty to where you're going to be by tomorrow. And so the area that you might be in that time tomorrow is much bigger than the size of your actual satellite. And so you get a lot of false alarms, but that's the best you can do. And so right now, every year, there are tens of thousands of dodging maneuvers going on as satellites try and avoid one another. and which is just insane.
These are all the people that played video games when they were little, right? This is their job now.
That was these avoidance maneuvers were very rare 15 years ago, say, and now they're happening every day. And it's just it is like a video game, and so that's great, but the tracking systems aren't perfect. The predicting systems aren't perfect. Eventually we're going to get unlucky and there are going to be more collisions. And the worry is that if you have enough big collisions, maybe, if you have one every 10 years, that's probably okay. But if you have a couple a year, if it gets so crowded and you get bad enough at avoiding them, that you get a couple a year, now you're going to start to get a chain reaction where debris from one explosion starts hitting other satellites and causing them, and then that carries on in a chain reaction. And that's called the Kessler cascade, after a scientist called Don Kessler, who predicted it way back in the 1970s. And so if that happens, you could basically lose access to Earth orbit because whenever you tried to launch something, it would just get hit by other debris. And so we want to avoid that. Right? It's the usual environmental problem, right? That it doesn't get bad overnight. You slowly start to choke in your own garbage over a long period of time. And it's very hard to get people to do anything practical about that until it starts really affecting the bottom line. And then by that time, it's kind of almost too late. And so we'll see. We'll see what happens. But right now, we're not. I believe that we're not on a great track. And people talk a good game about how we're improving, making less debris and stuff like that. But it is at a certain point, we're going to launch so many satellites that we can no longer control them.
What could a bad day look like? Like, what could potentially happen?
Well, the real fear is what if a half-ton satellite smashes its way through the International Space Station, killing everybody aboard? But also just, if two multi-ton satellites hit each other and you get thousands of pieces of debris and you in a particularly busy orbit over a period of time, and then you get unlucky and you have another one the same year, you could get into this situation where you're seeing this chain reaction going. And it won't go quickly, it'll still take years. So you always have time to clean it up if you get really serious about it, but it's going to be difficult and expensive to do.
Okay, I have questions about this graveyard. What's going on up there? Like, is that a problem? How many satellites are floating around in this satellite graveyard? And what's the threat up there? Like, are we using that part of space for anything that could be a problem?
Yeah, it's not so much a problem. So the critical resource is the geostationary orbit. And the geostationary orbit is a thin ring around our equator. So it's 23,000 miles up, and that's the height at which it takes exactly a day to orbit the Earth. And so if you're going around the equator once a day, and the Earth is spinning underneath you once a day, you stay above the same point in Earth as you go around. And so you can put your DirecTV dish on your balcony and have it point at one point in the sky and not have it scanning like a radar would normally do, right? And so that's why the geo is so valuable. And it's only about 1 kilometer thick, somewhere between 500 and 1,000 satellites now in geo. And they're all, their distance from the center of the Earth is the same to within less than a mile. So what you do is you boost them up another 250, 300 miles so that they take 25 hours to go around the Earth. And that isn't a particularly useful orbit. There aren't really active satellites out there. And there's probably about 1,000 to 2,000 dead satellites in that graveyard now. And it's a much bigger volume. You don't have to keep it near the equator. It goes 1,000, a couple thousand miles north and south of the equator, and it's 1,000 miles thick. And so there's a lot of space in there. Having said that, if you keep on doing that for another 100 years or so, you might have enough in there that every time you fly to the moon, you have to go through that region, and you want to watch out. If you have satellites exploding there, you could have a lot of debris that would be hard to track because it's so far out. So it's not a perfect solution by any means. But it's served us well for the past. They started using this graveyard in the late 1980s. And so it's served us well for 40 years. But yeah, I think in the long run, we're going to have to build recycling stations in space and take the retired satellites and go and build new satellites from their materials.
Sounds expensive.
Well, it does, but at the same time, once you have the infrastructure in place anyway for, it's not economically practical now. But if we're really building this spacefaring civilization where there's a lot of traffic going back and forth and a lot of maintenance happening, maybe that will become viable. And there are companies that are thinking about this already.
Mm.
So
what does that look like? Like a giant vacuum or like a big net?
Well, no, it would be like a space station, and you would have tug spacecraft go up and clamp on to a retiring space with a robot arm, and then truck it. Tow truck. You would have tow trucks.
Litter pickup. It's a little litter pickup.
Yeah, you would have litter pickup to the recycling plant.
What about deep space? Is there any space debris going into deep space?
Absolutely, and I'm pretty much the only person who's been trying to track that and catalog its orbits. It's not so much a concern for bumping into because, again, the solar orbit is big. Although there are a couple cases. So we had some rocket stages that were left in an orbit that goes beyond the moon in the Earth-Moon system, like a moon probe, and the rocket stage that sent it there goes near the moon and then beyond. And the trouble with an orbit like that is, if you boost it a little less, it's in a nice orbit around the Earth that doesn't go near the moon. If you boost it a little more, it goes into orbit around the sun, and it's just an asteroid, basically, and that has its own issues, but not as bad. But in this intermediate stage, it keeps feeling the gravity of the Earth and the moon and the sun, and the orbit is actually chaotic. And so it makes it very difficult to predict where it's going to go. And eventually it maybe smashes into the moon, which again is not so bad right now, but 10, 20 years from now, when there are moon bases and when there are delicate scientific instruments on the moon that don't want a cloud of dust landing on them and things like that, that might not be so great. And so I've made some progress in trying to persuade the space companies not to leave their rocket stages in these chaotic orbits, like either bring them back down or send them out in orbit around the sun, but don't leave them in this intermediate state where they're chaotic. And even if you put them in orbit around the sun, the problem is now eventually they come back near the Earth, maybe 20 years later, and the asteroid astronomers catalog them as an asteroid. because no one's keeping track of the fact that this was actually a rocket stage.
Oh,
So
gosh.
I've been working with the Minor Planet Center here at the Smithsonian to sort of document where the rocket stages are going, so that when they come back, when they catalog it as an asteroid, I can go, no, that one's not an asteroid. Don't worry about it. But it either requires the asteroid astronomers to spot it on the way out, or it requires the companies to tell us what the orbit was, which they're not always doing right now. And so we're trying to get regulation to go, you got to file a flight plan. It's fine for you to shoot it out there, but tell us where you're leaving it. And so, that came up earlier this year. It was an asteroid for a while called 2018 CN42. And it was cataloged in January from an old orbit data. And someone noticed that it was a bit weird because it had come really close to the Earth back in 2018. And I looked at the orbit and I went, that rings a bell. And I was able to go back and look at my data and tell the Minor Planet Center, actually, no, that's not an asteroid. That's a Tesla. That's Elon's sports car that he bolted to the front end of a rocket stage.
Oh my gosh.
Sent into orbit around the sun. And here we are 7 years later. And it was.
How did that not make national news? How do I not know this?
There were some news stories about it.
Okay.
But I guess, so that's just one example, right, of why it's kind of nice, not to have that on the books as, oh, this is a potentially dangerous asteroid that could hit the Earth. No, it's actually much smaller than an asteroid. It's just shiny because it's a sports car.
How close did it get to Earth?
Not very close in this particular time, millions of miles, but it will eventually come back closer to the Earth at some point. And so having a good orbit for it, so that the next time it shows up in another 20 years, we don't get unnecessarily excited about it, or, maybe, spend $1 billion sending a science probe to study this asteroid only to discover that it's not an asteroid when we get there. That would be super embarrassing.
Yeah.
So these things that, I think we're reaching a point where it's important to keep track of all the stuff that we're putting out there. And so I've made it my mission to make that happen.
Okay. So what about stuff re-entering Earth's atmosphere and falling from the sky? What's the threat of this? And is it only that stuff in that lower orbit that could happen with?
Well, or stuff that's in big elliptical orbits. So if you launch a communication satellite to geostationary, the rocket that launches it ends up in this very elliptical orbit that starts off at maybe a couple hundred miles above the Earth, arcs out to 23,000 miles, and then comes back down again. And then the satellite separates, and at the high point, it fires its engine to stay up there at the high point. But the rocket stage is left in circling the Earth every 12 hours in this very big loop. And each time it goes down to the bottom, it feels the atmosphere a bit. Its orbit shrinks a little more, shrinks. And so then 10 years later, it can come in and re-enter.
Is it controlled? Can you control
absolutely
that?
No, it's dead. It's dead within a few hours of launch. And so it's just a chunk of metal that's feeling the effects of the Earth's atmosphere. And it comes in at a very unpredictable place and time because of this elliptical thing. Every time it goes through the atmosphere, it loses a chunk of speed, and it's hard to predict exactly how much. And so also for the ones left in low circular orbit, they're a little more predictable, but even so, I might be able to tell you today that, this old satellite's going to re-enter tomorrow. And it's just been left in orbit. It's been dead for 10 years, and its orbit has shrunk, and now it's going to finally come down. And at a certain point, as it tries to plow its way through the denser and denser atmosphere, as it gets lower and lower, it heats up. That speed energy gets transformed into thermal energy. It gets hot, it melts, it breaks up, and now suddenly the pieces have a lot more drag than the original satellite, and it just falls out of the sky. But knowing exactly when that's going to happen as it circles the Earth is very hard to tell. And so today I might be able to tell you the thing that's coming down tomorrow is going to come down tomorrow in a 3-hour period, Well, in that 3-hour period, it's going to go twice around the Earth. And so I can tell you, who do I warn? I'm going to say, well, it's going to come down in Italy, or maybe Thailand, or maybe Australia, or maybe South America, right? And which isn't very helpful. And so you can't really give useful warnings to people about, oh, there's this thing that might fall out of the sky. You might be able to say, oh, if you live in India or North America, you're fine. But there's this like 20% of the world which still it might hit, and we don't know when. We don't know until after the event, usually. Like an hour afterwards, we get a measurement from one of the satellites that goes, we saw the infrared flare, it came down at this point at this time. But we can't accurately predict in advance. I mean, small satellites melt entirely, but satellites of a ton or more, it takes them so long to melt that that they haven't melted all the way through by the time they've slowed down with the friction of the atmosphere, and then they just fall out of the sky as a chunk. And they slow down, the reentry makes them slow down from 17,000 miles an hour to just a couple hundred miles an hour.
Okay.
So this happened 2 days ago to a Chinese rocket stage that re-entered over Australia. Something about 3 or 4 feet across, empty rocket casing. Fell out of the sky at about 100 miles an hour or so and hit the ground in Australia. And someone found it like smoking gently on their land. And it's just luck that it didn't hit anybody.
I was going to say, what's the chances? Do people ever get hit?
Yeah, no, it turns out that people only make up about 1/100% of the Earth's surface area. Right. So just from that fact, the chance that a random thing falling from the sky hits a person is about 1 in 10,000. But, we've had about 10,000 reentries by now. So eventually we're going to get unlucky. There was one documented case back in the 80s of some poor woman who got tapped on the shoulder by a gently floating tiny piece of space debris, got a small bruise from it. No big deal. But that's the only case we're aware of.
Wow.
The case last year was a narrow shave where a very dense chunk of metal from the International Space Station that had been jettisoned a couple years earlier re-entered over the US, went through the roof of some dude's house in Florida, landed on his living room carpet in the room next to where his kid was playing. And so that could easily have been really bad. But again, we just lucked out. So there has been minor property damage like that. There have been close shaves, but no fatalities yet. But I really think we got to stop these uncontrolled reentries of large space objects. I mean, the norm again has been evolved to be, if you have a big satellite, what you do is you put a rocket engine on it, and when you're done with it, you fire the rocket engine to bring it down over the ocean under control. And then you can issue a warning to ships going, stay out of this area between 3 and 4 p.m. and dump the thing in the South Pacific or somewhere, or the Indian Ocean or somewhere. And that's like the gold standard of what you should be doing. And for the biggest spacecraft, that generally happens. But there's this intermediate range of a few tons where people don't always bother. And I think that's got to change.
Do you think there's a time period in the future that we should be looking at where there was a lot of activity, where that we're going to get a massive amount of objects coming back in and re-entering?
Yeah, I will say this. So right now, the bulk of the new satellites are these SpaceX Starlinks. They are designed to melt completely on re-entry, even though they're very big. We're not sure we really believe they melt completely, but they melt mostly. And so they're actually, even though they're the bulk of the re-entries, they're not the biggest risk. Because of that design, what effect they're having on the chemistry of the upper atmosphere is still a bit uncertain. So there's that. But in terms of bonking you on the head, I'm more worried about some of the Chinese rocket stages, like the one we saw a couple of days ago. There's also a risk to aviation. Even a relatively small piece coming from space could depressurize an airliner. We saw a case a few days ago that was initially blamed on space debris, United Flight 1093 flying over Utah had something smashed into its windscreen and cracked the windscreen and injured the pilot. It now turns out that was a weather balloon flying at a similar altitude to the plane and not space debris. SpaceX, there was a possibility of a SpaceX thing and they're now exonerated. I want to make that clear. It wasn't SpaceX's fault. Weather balloon. But it could have been, right? It could have been space debris. And you could, in principle, lose a passenger plane. Now, we don't think that would happen often. There's probably a 10% chance that it would happen sometime in the next decade or something like that. That's not so small. I mean, it's like one plane every 100 years, right? So a 10% chance of a plane loss in a decade. So it's not huge, but it's not tiny. And so we have called for stricter regulation of uncontrolled reentries for that very reason.
If you got to decide how everything went from this point forward, like what's your dream for the future of all of these rockets and satellites? What's best practices?
Best practice, yeah. Well, I would say first, we have to get the Chinese on board with international space traffic control, basically. That has to be led internationally. I think it should be led initially by the Europeans and the Japanese, say, because if it's led by the Americans, the Chinese won't play. And if it's led by the Chinese, the Americans won't play. But I think if you have other parties leading it initially, it can grow to include both the US and China ultimately. So that's one thing. I think we're going to have regulations on, who can be in what orbit and so on, how to share the resources equitably. I think we have to ban these uncontrolled reentries of large satellites. I think we have to require proper flight plans for deep space missions. And we have to revamp the UN Space Registration Convention, which right now is sort of like, you got to tell the UN you launched something, but it can be like a year later if you like. That's not okay. We need to modernize that. And there's no reason in this age of internet, social media, and so on that your international UN database can't be updated within 5 minutes of launch and keep being updated as the satellite changes its orbit and things like that. We really need that kind of public data sharing so that we can all use this incredible resource of outer space in a sustainable and safe way.
Dr. McDowell, is there anything else you want to add? This has been really fascinating.
It's the usual story, right? Which is new technologies bring amazing advances. I want to emphasize, people don't realize how much of their everyday lives is underlaid by space activities and space communications. I mean, you all know about GPS, but, a lot of the Internet of Things stuff goes over space. A lot of our knowledge of climate change comes from space satellites. Banking and other things like go over space communications links. Our networked world, right, is integrated by this space network of communications. And so, there are incredible benefits from the new space age. But as with any human activity, these things have to be managed so that they don't, so that they don't trash the environment. And so I want to see a very active space future, but one that's appropriately regulated so that these activities can flourish, but we don't trash the environment while we're doing it.
Jonathan, thank you so much for your time today.
You're very welcome.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. Also, please rate and review the podcast on Spotify or Apple. Thank you to Dr. Jonathan McDowell for educating us on space debris. Dr. McDowell has a website and a newsletter where he tracks everything in space. So if you're interested, go check it out. Thanks to the National Weather Desk and Sinclair Broadcast Group for their ongoing support of the podcast. And as always, my associate producer, Brian Petras, for his help with today's episode. I'm meteorologist Emily Gracie. Make it a great day.